So we were studying about metals and non-metals in the previous class, isn't it? In metals and non-metals, we learned about the the physical properties of metals and non-metals. Then we learned about its exceptions, and then we were into the reaction. That means chemical reactions of metals. Okay. So we learned how metals react with oxygen as well as water. The next is every metal when it react with a dilute acid. Okay, we need to make the acid very dilute. Then we get the corresponding salt plus hydrogen atom. Hydrogen gas. So this reaction we have already learned in our acid, bases and salt. Like acid react with metal to release hydrogen gas. So almost all the metals will react with dilute acids to give salt plus hydrogen. But there is some peculiar property for one of the acid, which is the HNO3. Okay. If it is HNO3, a metal reacting with HNO3 will give us the salt, but instead of hydrogen gas, it gives water. Now, how the water comes is this HNO3 is a strong oxidizing agent. What is oxidizing agent? Anything or any agent which helps in the addition of oxygen. So what HNO3 will do is HNO3 will give oxygen to hydrogen, so it becomes water. So this is the exceptional acid. Like when metal react with HNO3, it will not give you hydrogen gas, instead it will give you water. Okay. So the happy thing is that there are two metals, okay, exception for this also. That is magnesium and manganese. Okay. So these two metals will release hydrogen gas. It will not convert it into water. So this is the third reaction of acid, sorry, not acid, metal. That means metals reacting with acid. So normally it gives you salt plus hydrogen gas. Now we will see how one metal react with the solution of another metal. For example, metal A. Okay, it react with, the salt solution of another metal B. Okay, salt solution of metal B. Solution of metal B. Okay, so what actually happen is that if metal A is more reactive than B, then what you get is salt solution of A. Okay, salt solution of A plus metal B. That means metal B will be replaced. This we have learned in our first chapter that, for example, our iron is very reactive. Okay, if iron is put in copper sulfate, CuSO4, you know that iron will replace the copper. So the sulfate, the solution will become FeSO4. And who will be replaced? Your copper will be displaced. Okay, so this is the last reaction of our metals. So we have four reactions: metals with oxygen, okay, metals with water, metals with acid, and metals with solution of salt solution of other metals. So these are the four reactions from which we will finally conclude into the reactivity series. So as per the reactivity series of all these metals what we have seen, okay, so the highest reactive is potassium, then comes sodium, then comes calcium, then comes magnesium and aluminium. Okay, these are the five metals which end with IUM, aluminium, yum. Okay, after that comes the next ZIL. You can remember it as ZIL: zinc, iron and lead. Okay, this. Then comes the neutral one, which is the hydrogen, and lower than hydrogen will be your copper and mercury. Okay, copper and mercury. And the least reactive metals are silver and gold. Silver, gold comes at the last session. So this is how the reactivity decreases, and this series we call it as reactivity series. Now what we need to learn is regarding how a metal react with non-metal. how a metal react with a non-metal. Okay. So as we discussed earlier, metals are someone who releases electron and become positive. For example, sodium. Atomic number 11. Electronic configuration 281. Not stable. It has to leave an electron. So sodium will leave an electron and will become Na plus. Whereas a non-metal, for example, chlorine, atomic number 17, configuration 287. So it will accept one electron and Cl will accept an electron and will become Cl minus. So let's see the same thing in the dot formula, electron dot formula. Sodium has one electron in the outermost shell. Okay. And what about our chlorine? Chlorine has 1, 2, 3, 4, 5, 6, 7 electron in the outermost. So what will happen is this sodium is ready to give one electron to chlorine. So Na will become Na plus and Cl will become Cl minus, and a bond is formed between both of them and the compound formed is NaCl, and we call, as this bond is formed by the transfer of ion, it is called as ionic bond. Ionic bond. For example, if you take sodium, okay, instead of sodium, if you take magnesium, you know that magnesium atomic number is 12, 282. So outermost electronic configuration is 2 electron. Okay. So definitely there will be need of 2 chlorine because one chlorine can take only 1 electron. So when we take the chlorine 1, 2, 3, 4, 5, 6 and then 7. 1, 2, 3, 4, 5, 6 and 7. So it is very clear that this electron will be taken by this chlorine, this electron will be taken by this chlorine. So Mg will become Mg2 plus, and how many Cl minus? 2 Cl minus will come. So this will form a magnesium chloride. This is also an ionic compound. Okay. So when a metal react with a non-metal, actually ions will be formed, and the bond which is formed with the help of exchange of ions, we call it as the ionic compound. Okay, or ionic bond, or the compounds formed are called ionic compound. There are 4 properties for ionic compound. One is that physical state of ionic compound, it is solid in nature. Second is it has high melting and boiling point because there is lot of attraction between the ions. Third one is that they are, all ionic compounds are soluble in water but not soluble in organic compounds like kerosene and all. Okay. And then conductivity of organic ionic compounds are very high because conductivity is normally conducted with the help of ions. So this is there on uh, page number 49 as 4 different points, and it is very much repeatedly asked for the board exam. So next class we will study about how metals occur in nature and how we are going to extract the metals.